Hey everyone, and welcome to this explainer on application frameworks. I am absolutely thrilled to be guiding you through this session today. We are covering a core part of the software engineering curriculum here at Edivos, looking specifically at section 15.2 from your textbook. Application frameworks represent a massive, and I mean massive, leap in how we actually build modern software. Mastering this concept is going to be absolutely essential for your development as professional software engineers, so let's just dive right in. Okay, here's our quick roadmap for today's explainer. We're going to look at the shift to frameworks, then dive into web application frameworks and their standard features. After that, we'll tackle the crucial concept of inversion of control, look at a few other framework types, discuss some of their downsides, and then we'll wrap it all up with a summary in your exam focus.
All right, part one, the shift to frameworks. So to really understand why we use frameworks today, we actually have to take a quick step back and look at the early promises of object-oriented programming, or OOP, and why those initial ideas kind of had to evolve. You see, early OOP promised that we could write single, fine-grained objects and simply reuse them everywhere. Sounds great, right? Well, experience showed us this didn't quite work out in practice. These individual objects were often just way too hyper-specialized for specific applications. It turned out that it often took a programmer longer to figure out and adapt a tiny, fine-grained object than it did to just re-implement the whole thing from scratch. Because of this, modern software engineering shifted towards reusing much larger-grained abstractions. And these larger structures, those are what we call frameworks.
So, what exactly is a framework? Let's look at the formal definition from Schmidt and his colleagues. They define it as an integrated set of software artifacts such as classes, objects, and components that collaborate to provide a reusable architecture for a family of related applications. Now, to put that into much simpler English for you, think of a framework as a generic skeleton architecture. It gives you the core structure and those standard generic features straight out of the box, and then you, the developer, get to extend and customize that skeleton by adding the specific flesh and skin required for your unique program. So the really big takeaway from this first section is just this. Early OOP kind of failed at scale because reusing tiny objects was super inefficient. Today, modern software engineering relies heavily on frameworks because they provide a highly customizable skeleton architecture built through extensible object classes. And that is what allows us to achieve major real-world design reuse. Moving right along to Section 2, Web Application Frameworks and MVC. Let's bring this into the real world by focusing on the most widely used type of application framework out there today, the Web Application Framework, or WAF. A WAF is specifically designed to support the construction of dynamic websites. And if you're wondering what a dynamic website is, it's simply a site where the content actively changes based on user interaction or live data, rather than just displaying the same static text to everyone. Now, pretty much all modern WAFs are built heavily upon a specific architectural structure known as the MVC design pattern. Let's break down exactly what that means. This structure from your textbook brilliantly illustrates the MVC, or Model View Controller pattern. This is a foundational concept, so stay with me here. MVC basically separates the state of your application from how it's actually presented. Let's step carefully through this. The model encapsulates your application's state and data. It is the absolute truth of your system. The view defines how that exact data is presented to the user on their screen. On the controller, well, that manages the user's interactions, like key presses or mouse clicks. So when a user interacts, the controller updates the model. The model then lets the view know that the state has changed, and the view requests those specific updates so it can render the new presentation. It's an incredibly efficient way to separate concerns within your program. Just to quickly wrap up this section, MVC is definitely the central architecture for web application frameworks. But it doesn't work all on its own. Frameworks also rely heavily on other structural design patterns, like the observer pattern, the strategy pattern, and the composite pattern. Without these abstract and concrete classes allowing for real extensibility, frameworks would honestly be completely impractical for us to use.
All right, part 3, WAF standard features.
So when you actually adopt a web application framework, what do you get straight out of the box? Well, there are 5 core features you absolutely need to know. First, security. Second, dynamic web pages. Third, database integration. Fourth, session management. And fifth, user interaction. Grab a pen and write these down slowly and carefully, because I promise you, they're a required concept for your upcoming tests. Let's explore how each one of these functions. Let's walk through them step by step. Number 1, security. WAFs provide built-in classes to handle user authentication, like your login screens, and access control, ensuring users only see what they're actually allowed to see.
Number 2, dynamic pages. You get classes to define web page templates that automatically populate with dynamic data. Number 3, database integration. Now, while the WAF doesn't usually include a database itself, it gives you an abstract interface to easily connect to databases like MySQL. Number 4, sessions. Frameworks manage the super complex task of tracking a single user's multiple interactions over time. And finally, user interaction. They provide AJAX and HTML5 support, which allows for highly interactive, device-independent interfaces that just adapt automatically whether you're on a mobile phone or a tablet.
Okay, Section 4, Inversion of Control. Listen to me very closely right now, because this is an absolutely critical, non-negotiable exam concept that you must fully grasp. I'm going to pose a question to you. Who is calling whom in your program? When you use a standard programming library, let's say a math library, your application code is firmly in charge. Your code calls the library function exactly when it needs to calculate something. But what happens when you use a framework? And that brings us to the definition of inversion of control. In a framework, the framework objects, rather than your application-specific objects, are responsible for the control in the system. Let me say that again for emphasis. In a framework, your code does not call the framework. The framework calls your code. The control is completely 100% inverted. Let's look at how this actually plays out mechanically. The framework contains what's known as the main event loop, and it is constantly listening for inputs from the GUI or the database. When a user clicks a mouse, the framework actively recognizes that event. It then uses what we call callbacks or hook methods to trigger the specific application classes that you, the developer, wrote. You basically configure these hook methods so the framework knows exactly which piece of your custom code it needs to execute in response to the user's action. Think of it like this. The framework drives the car, your code just tells it where to turn. Section 5. Other frameworks and, crucially, their downsides. Now, web application frameworks are definitely the most popular, but they aren't the only ones out there. Researchers Fayad and Schmidt actually identified 3 other framework classes. First, system infrastructure frameworks, which support things like compilers and underlying user interfaces. Second, middleware integration frameworks, like Microsoft's .NET or Enterprise Java Beans, and these provide standards for component communication. And third, enterprise application frameworks, which are built for specific domains like telecommunications. Though it is worth noting that enterprise frameworks aren't widely used anymore. They've largely been superseded by software product lines, which is a topic we'll cover in a future lecture. But hey, let's be real for a second. We really need to ditch the myth that frameworks are some kind of flawless, magical tool. They have very significant downsides. First off, they possess incredibly high complexity. It can literally take a development team several months just to learn how to use a new framework properly. On top of that, evaluating which framework to choose in the first place is expensive and tough. But the absolute biggest headache? They are notoriously difficult to debug. When an error occurs, it often happens deep inside the framework's own code. And because you didn't write that code, and you might not fully understand how the framework's internal methods interact, debugging can become a total nightmare. So just to quickly recap that section, yes, frameworks are exceptionally powerful tools that will eventually save you a massive amount of time. However, that benefit comes at a real cost. The initial complexity, the steep learning curve, and the severe debugging challenges are significant realities that you are going to face as software engineers. And finally, Section 6, Summary and Exam Focus. All right, we have covered a lot of ground today. Here is exactly what you need to lock in for those upcoming tests. Number 1, you must be able to clearly define inversion of control. Remember, the framework calls your code, not the other way around. Number 2, you must be able to explain the model view controller pattern and how it elegantly separates state from presentation. And number 3, you must be able to list and describe at least 3 of the 5 standard features of a web application framework, like security, database integration, or session management. Learning how to master a framework is hard work, I know, but it is absolutely essential for modern software engineering. Honestly, it's the only way we stop ourselves from reinventing the wheel on every single project. In our next topic, we're going to build on this concept by looking at software product lines, and we'll explore how entire families of applications share common architectures. I want to leave you with a final thought to chew on as you continue your studies here at EduVas. Knowing that debugging is incredibly difficult and that control is fundamentally inverted, how will you utilize frameworks to streamline your next major software engineering project without completely losing control of your overall architecture? Think deeply about that. Thank you so much for joining this explainer, and I will see you all in the next session.